Hello, this is Mr. Stansbury. I'm going to take you through the notes on absolute value equations and inequalities. At the end of this, you should be able to say, I can write, solve, and graph absolute value equations, and I can solve and graph absolute value inequalities. Okay, so first thing, absolute value. Absolute value is the distance from that number to 0. So the absolute value of 8 is going to be 8 because the distance from, let's get a better color here, let's see, so the distance from 8 to 0, this distance right here is a distance of 8, and then from negative 8, the absolute value of negative 8, that's still the distance from negative 8 to 0, so that distance there is also 8. Okay, so again, it's the distance from that number to 0. That's the one way to look at it. Hopefully make more sense. So let's take a look at some examples here. Solve. We got absolute value of x plus 3 minus 1 equals 7. So just like a normal algebraic equation, you want to try to get x all by itself. So first thing we're going to do is let's get rid of this 1. So let's subtract 1. So we add 1 to both sides. Right? And we get absolute value of x plus 3 equals 8. Okay, now, here's the thing. This absolute value here, we know that this number over here can either equal positive 8 or it can equal negative 8. If this equals negative 8, that distance, that absolute value will be 8. And if it equals positive 8, the absolute value will also be 8. Okay, so what we want to do is say, oh, x plus 3, we want to set that equal to 8, and then we also want to set x plus 3 equal to negative 8, because again, if inside here it's positive 8 or negative 8, it's going to be correct. So we've got to solve it for both. So on this one here, we subtract 3 from both sides. X equals 5 is one answer, or subtract 3 from both sides here, and we get x equals negative 11. So we actually get two answers. So I know some people are confused by that and say, wait, how in the world would that work? So let's just to show you, let's plug it back into what how about this? Let's make it easy. Let's plug it back into this one, because this is really the same as this equation up here. We just move the 1 over. So we take the absolute value of x, we said 5 plus 3. Does that equal 8? Well, 5 plus 3 gives us 8. Absolute value of 8 equals 8. That one works. Check. That's a check mark. Pretty bad check mark. But okay, and then this one here, we do the same thing. We're going to do x plus 3, absolute value. Oops. We know what x is. We know that x is negative 11. So on this one here, this x plus 3 equals 8, absolute value. So we're going to do negative 11 for x plus 3. Does that also equal 8? Negative 11 plus 3 is negative 8. Absolute value of negative 8 does in fact equal 8, so they both work. So both of these answers are correct. So make sure you come up with both. Don't just stop with one. Make sure you find them both. Okay. B here. We're going to solve this thing, do the same thing, get rid of this positive 4, subtract 4 from both sides, and we get 3 times the absolute value of x minus 2 equals 9. Okay. Now, we really want to get this absolute value. It's pretty important when we're solving these. You want to get the absolute value all by itself. So you want to get it all by itself on one side, and then that's when we can split it up into these two different equations from here. Okay. So what that means, what we want to do over here is divide both sides by 3 first. Then we get absolute value of x minus 2 equals 9 divided by 3 is 3. So we now know that x minus 2 can equal positive 3, or x minus 2 can also equal negative 3. Okay, that's when, once you get the absolute value all by itself on one side or the other, that's when you can split it up. And then it's just basically going to be plus or minus 3, whatever this number is over here. Just like this was 8, we did plus 8 and minus 8, positive 8 and minus 8. Okay, or negative 8. So now last step is to solve. Add 2 to both sides. We get x equals 5 here, or add 2 to both sides here, And we get x equals negative 3 and 2 is negative 1. So both of those answers will work. And again, you're welcome to plug those back in if you want, but you do not have to. Okay, and then let's try this one. Subtract 3 from both sides. 2 times the absolute value of x minus 4 equals negative 2. Okay, so then we divide both sides by 2. And we get absolute value of x minus 4 equals negative 1. Okay, now, this should hopefully bring up a nice red flag right here. You're like, whoa, wait a minute, red alert, red alert. Something's goofy here, because how you cannot have absolute value is the distance from this number to 0. You cannot have a negative distance. There is no way to have a negative distance here. So this one here, no solutions. Okay, that will not work. Okay? Okay. Now, solve each inequality, graph the solutions on a number line. So these are our last 3 examples. But before we do this, let's take a quick little comedy break.
Those McDonald's fries are truly amazing, right? Has your mother ever made anything as good as a McDonald's fry? Not even close. We lie to ourselves when we eat McDonald's fries. We're like, oh, they're so thin, they couldn't be fattening. You ever eat too many McDonald's fries? Of course not! There's never enough of them. There's always that moment when you're eating McDonald's fries where you're like, what happened? Where'd they go? Then you start scrounging for the fry crumbs. You're like, oh, that's just a piece of paper from the straw. But it was touching the fries, so.
All right. Last 3 here. Solve each inequality, graph the solutions on a number line. So we're going to do the same thing, and then at the end, all we're going to do is just graph it onto a number line. Now, it's important to notice here that these are inequalities. Notice it's not an equal sign here, okay? So what I like to do is I like to start off just kind of pretending that that's an equal sign. And if you'll hopefully remember from algebra, the only time you need to flip this sign around is if you multiply or divide by a negative number is when we need to switch that sign around, right? So first thing, we're going to subtract 2. We're not multiplying or dividing, so we don't have to worry about flipping anything around. X minus 4 is going to be greater than 6 minus 2 is 4, okay? Okay, so once we get to here, remember what this is, we've got the absolute value by itself, so this is where we got to split it up into 2. So we're going to do the same thing. X minus 4 is going to be greater than 4, or now we do this, x minus 4, and then this 4 is going to turn into a negative 4, and then we also have to switch this sign around. So since this is a greater than sign, now it turns into a less than sign, and then now we solve both, okay? Add 4 to both sides, and I'll show you how this works out when we're all done here. Okay, so we get x has to be greater than 8. 4 plus 4 is 8. Or, let's see, add 4 to both sides, and we get x has got to be less than 0. Okay, so to graph this thing here on a number line, you simply can do this. I like to put my smallest one on the left, biggest one on the right. Got our little arrows here. X has got to be greater than 8. So greater than, but not equal to. So maybe let's try this in a little bit different color here. So we'll do this, greater than, okay, but not equal to. And then X is less than 0. So here's 0. It's got to be less than 0. Okay, so just to show you that this is going to actually work out here, let's plug a number in for each one of these. So what's like a simple number greater than 8? Let's just do, say, 10. So if we do on this part right here, I'm going to simplify with that. 10 minus 4, absolute value, is that greater than 4? 10 minus 4 is 6. Absolute value of 6 is indeed greater than 4, so that one works. And then we got to find a number that's less than 0. So let's just do -1. So -1 and -4, absolute value, is that greater than 4? -1 and -4 is -5. Right? And then the absolute value of -5 is 5. 5 is greater than 4, so that works out as well. 6 is greater than 4 over here as well. Okay? So anything in the red there, that is going to be what any of those answers will work. Anything in between that will not work. And 0 or 8 will not work either because it's not equal to. Okay? All right, let's take a look at these last two, and then away we go. Let's see. First thing, add 1 to both sides. 3x plus 2, absolute value of, is less than or equal to 8. So now we're going to split it up. So we got 3x plus 2 is less than or equal to 8, or 3x plus 2 is greater than or equal to -8. And we solve both of those. Subtract 2 from both sides. 3x is less than or equal to 6. Divide by 3. X is less than or equal to 2. And then over here, subtract 2 from both sides. 3x is greater than or equal to -10. Divide both sides by 3, and we get x has to be greater than or equal to -10 thirds, which is -3 1/3, right? Or -3.3 repeating. I like 3 1/3 because then you don't have to do any rounding or anything like that. So when we go to graph this thing, again, all you got to do is put the smaller one on the left, -3 1/3, the larger one, 2, on the right, and then we graph this thing. So this is, for the 2, x is less than 2, less than or equal to. So since it's less than or equal to, we color in the red dot, and that goes this way, right? And then x has got to be greater than or equal to -3 1/3. So there's our 3 1/3, and then it's greater than, so it's going to be everything in between those 2 points. Okay? All right, last one. Subtract 3 from both sides. Absolute value of 2x minus 5 has got to be greater than -1. So we have an absolute value that is greater than -1. That's where our big red flag comes into play. You cannot have the absolute value of a number. Let's see. Oh, hold on. Let me back up here for just a second. Since it's an inequality, this actually, get rid of my red flag. So it's basically saying, what number can I plug in here so that it's greater than -1? Every absolute value is going to be greater than -1. So that's going to be all real numbers. Okay, so I guess we really could graph that on a number line, and it's going to basically be, the red is going to cover over this entire thing here, right? Oops, that and that. Okay, that's all we have for the absolute value equations and inequalities. If you have any further questions on this, please feel free to ask. Thanks.